if anybody's watched this after the fact. I am just waiting for the time to start here, and then we will get underway. So. Yeah, I don't know, as far as adding closed captioning, I tried to find that setting. I looked everywhere. I don't remember. I was trying to look for it last night. I might have found it now. Welcome. I'm going to start here in just a second. But I looked, and it's oddly enough said something somewhere that it will just automatically start working as long as my streams are considered eligible or something. But I'd look around, and maybe just the fact of me looking around and making some tweaks to some of the settings turned it on. I don't know, but I'm glad you're seeing it. So. Hopefully the voice recognition stuff will do okay with what I'm saying. And so it's starting time. Welcome everybody that's here. I am going to go ahead and get going. One of the things that we have today that should hopefully be nice for people is I've adjusted my camera angle. I now have the camera directly above me. There's a disadvantage to this in that it's not zoomable because I had to get a really wide angle lens to be able to get the whole shot in. But I think it's a lot more visible to you guys what I will be working on from this higher angle directly above the chassis. So if for some reason you guys think it's not working out, let me know. I will maybe pull it back down from up there. We'll have to deal with me doing a little bit of moving the camera and getting my tripod back over close up, but we'll figure that out as we go. But today, as you can see up in this top left corner now, I've got to focus on what I'm going to try and do is start to wire up the things that are related to the potentiometers. Anything that doesn't go directly into the board, I'm going to try and connect, hook up, and wire up as best I can. So one of the first things I'm going to need to is get this bus bar that I have here. And the way I tend to do a bus bar is I have one end of it that I will hook into the last node here at the far end. Oh, yeah, that's not going to work. I got to try and adjust my picture because it looks like it's sitting right on top of where I'm trying to show you. So this is one of the things I'm a little bit worried about is how I can, maybe I'll set this down here because I won't be working in that area of the screen. So, I can turn off this now as well. Boom. All right. So this guy, let's put it down below because I'm going to be working up in the top area there. So, all right. Hello, Peter Johansson. Welcome. What's interesting? Just seeing the top view here, or I think this might be the first time I've seen you joining, but at any rate, I'm going to let me go back now and show you what I was talking about. The bus bar will connect in here and here, and I just leave this bus bar kind of attached to the pots themselves. It's lightweight metal, so to me I don't think it's a problem, and then I can connect any other grounds that I need to it as well. So I just have to get my soldering iron up, remove the ground that's here a little bit because it's kind of in the way, but I can pull it back in again after I get things reconnected. But although another thing I'm debating is that, from what I understood, Dumble tended to, I've created a single connection point right here. That connection point is where all the ground should really end up tying into, so I might actually just use that as the ground connection as well. So, but and I've got a couple of grounds here. I believe I'll double check that are supposed to also tie into that same ground point, so we'll kind of tie those in as well while we're at that input ground point. Oh, you're looking at that mid control. Yeah, it's a lot about what he does is very interesting, honestly. But yeah. Kind of weird that how do I explain that? So it basically is taking it's just shunting a specific variable frequency to ground at that specific spot. We could actually kind of look at that on the schematic really quickly, which is right here. No, that's that. So here, and let me get back up there in the schematic. The mid pot, if that is probably going to be, let me just zoom in a little bit more, and I will adjust the positioning of it a little bit. So here's like treble, and right here you can see middle. So the middle is this coming down off the 0.05 into the middle wiper and then down. So it's just kind of, I guess it would be more of a variable resistor to ground through the mid pot as to how much of that mid frequency is being shunted, and then it comes over to the base on this side. So yeah, it's a little different. It's not the typical, as I recall anyway, I think usually in the Fender style tone stack, I think it mid goes to ground as well instead of just being a variable resistor ground. So, but I'm not positive. Oh no, maybe that's more of some of the stack ones, but that's the schematic as you can see. So the top end is not connected, wiper is coming in and then goes off to ground to the bus bar. So larger is better. Yes, I know, especially for people like me. I have to wear glasses and be able to read anything nowadays. So all right, so I'm going to go back to the layout, and we will start whacking away at this thing. So let me turn on my fan. Of course, I'll apologize again if this is a little annoying once I turn the fan on, but I don't want to be choking myself. So I will first get this bus bar in place, and the first part will be, honestly, I'll just solder in that first little spot right there, because that is going to be the easy one. That is the ground on the master volume. You can see it in the master. It's just kind of jumping up to the little bus bar that they show across top. So that's the first one I'm going to solder in on the master volume. It's a little dark with me leaning over, so I apologize, but maybe I can adjust the lighting a little bit this way. Is that a little better? Oh, I shouldn't be leaving this heat on this pot for so long. And now my solder just wants to fight me and not come over. There we go. Good to go. And let that harden up, and then afterwards, and so one of the things you'll see, there's a lot of little grounding wires that are part of the old amp, and I'll have to kind of pull those and cut those once I get to that point, but usually way to calculate mid. So you mean for bass guitar? The best way to do that, there's an app out there called Duncan Tone Stack Calculator, and that is a really good app because, let me see if I can just pull it up and we'll show it to you. I'll try and find it, and I'll show it on the screen. And I'm not an expert on what the specific mid for bass would be, but the Duncan Tone Stack Calculator is a free app you can download for Windows. And let me bring this up here. And you can see it up in the kind of corner there. The Tone Stack Calculator is, that's kind of hard to say for sure, but pull up this. So it's duncanamps.com/TSC. He also has several other apps, but you can basically tweak all of these parameters if you want to and try and adjust for different types and different types of tone stacks. I don't know if I have it on this machine. I do. Look at that. Okay, so I've put it on a lot of my machines, but not all of them. So the nice thing about the Tone Stack Calculator is that you can load up specific tone stacks. There's a Marshall, there's a Fender, there's the Vox, and then what you can do is play with them and adjust values. And so you can try, so you can see here, I think one of the big differences you're noticing is the mid goes to ground, but it also is a little different, but also the bass is kind of floating above it. Yeah, so that, but for bass guitar, generally I think, and I'm not great with this, but you want the frequency sweep to be a little different, and sometimes bass is especially good to have, instead of just a single mid, two different mids, so you kind of get different frequency ranges, or a sweepable mid, which allows you to kind of adjust the frequency itself, so that it kind of makes this dip in the mid control move. So mid is what's going like this, and either cutting or raising up your part. So the bass, quite often, you want the value of the mid, you want to change that to something else. Let's try, like 60, oops, that's the wrong machine, 60 nanofarads. And I'm just making up that number, but if you hit enter, you'll see it shifted left a little bit. And for a bass guitar, I do know there's generally a little bit more optimal frequency ranges. So a bass guitar, it's all about tweaking those capacitance ratings for where you want them, or you could even put another stage in the middle that you call mid-low and mid-high. And then you could kind of have two different mid-ranges to adjust for your bass. So does that make sense, Peter? All right, so I will go ahead and close that guy back down. No, I don't want to save it, but I do love that app. It's really cool. I've played with it before, and you can really try to tweak some different stuff and get yourself a sense of what you want. So back to the amp building. So, but I do welcome those kinds of questions. I want the whole kind of thing, the live streams, I want it to be an interactive process where you guys are telling me what you want to know as well and what we can discuss. So please do chime in with questions. All right, so this is definitely cooled, and so one of the things I noticed is that for this main volume pot, the ground that was already there is kind of fighting me. I couldn't get the my thick gauge wire in it, so I'm going to desolder it, and then I can drop this guy in. I might have to adjust a little, but all right, there we go. Now we'll solder that guy in. And one of the things I did is this wire that I do have has a lot of corrosion on it, even though it's aluminum, but I just took sandpaper and just wiped up and down it like crazy so that the solder would connect to it a little bit better. Alright, there we go. So my ground is, oh, you know what I just did, like a bonehead? I need to put a small wire inside there, so I'm going to reflow this, but I actually need to create a better ground connection to that terminal, because right now the way the ground is working in theory is it would still work because the pots are grounded to the chassis, and I've grounded to the pot, but the pots can slowly come loose and corrode over time, and so that's one of the reasons why, for example, right now I'm going to put in this grounding wire that will come over and connect to that ground. So I won't solder that ground in to that grounding point of the amp until I got multiple different soldered connections in there, but I do want to reflow this so I can, there we go. That's reflowed better now. Oop, that moved. It's just, so if you ever see motion after you get done soldering, go reflow it again, because you've created potential microfractures. So, all right. You found that the James stack works better for bass. Yeah, I think the James is really good. They call that either the James, or I think it's also called the Bandaxol or Baxendol or something like that. But I think those are both roughly the same stack. I think that was one that the Ampeg V4B and V4 uses as well, or is at least a variant of that, because it's so much more quality in the way it handles the bass, the way it's kind of frequency sets for the bass. All right, so let us see. So got that connected. One of the things I need to do right now is I need to get myself a small grounding lead connected to my input wiring there, and I am using a coaxial RG59U, like is specified here. You can even see that in the top corner of the above the level for the OD. It says Handy RG59U. I don't have Tandy, which is what Dumble would use, but I do have the RG59U so that I can get a little bit better quality shielding. It just makes them a little bit of a pain in the butt. These really thick gauge wires and really thick things can be hard to, they don't bend very well, but that's what he used, and I'm trying to reproduce that. So what I'm going to here is now also quickly create a soldered connection between the grounded shield of this cable and then a single wire that I can run to a ground, and then I'll put a little bit of I'll run up a little bit of shrink wrap so that it's kind of protected from accessing other things it shouldn't. So unisolated input jacks. So that's one of those areas, for example, that Marshall always uses isolated ones. Fender always uses isolated ones, or unisolated ones. I don't know the best answer to that. I think it's just a preference thing. You can create ground loops if you're not careful, if you're using isolated input jacks. But I think part of that is really more of if the higher current things, like your input, your output stages and whatnot, are not grounded well so that they have a very fast, easy path to earth, then that increases the chance of it. But as long as you do a good job of doing the rest of that work, then you shouldn't really have to worry about it too much. Man, this is not wanting to go in. There, I think it went in. Okay, cool. The braided wire didn't want to drink up that solder very well, but I think I got it to go now. All right. Does that make sense, Peter? All right, so, but yes, I mean, I think that's why some people use it mainly because it guarantees you're not going to have interaction of accidental grounding loose. But at least that way, you guarantee a much, you guarantee that your grounding point is exactly where you want it to in one single point. Now, one of the things the Valve Wizard talks pretty heavily about that I liked is how the grounding point should specifically be known and all to one single point, or a star bus, or some of those kinds of things. But Dumble used more specific. He has like 5 different grounding points in this, because he's got one grounding point for the high, the high voltage heavy output stage, another one for the input like power voltage, and then for kind of the middle level things, and another one for the earliest preamp stage. And I think there's a third one somewhere else if I'm trying to remember where that is. Basically, so that each one is distanced from each other on purpose to be sure to allow that kind of stuff. If we look at this layout, you can see they number them. This is ground number 5 right here, ground number 4. So ground number 5 is just for all the power supply filtering and cleaning and whatnot. Ground 4 seems to be, as I recall, related to the heaters and the bias circuit. That's what I think that's what that is. And then ground 3 is connected to the power tubes, as is ground 2. I think he just grounds each half of the circuit there. And then ground 1 is up here in this top corner right by the input jack, and that's where I have the one here that we're talking about in setting today. So that grounding is very critical and can be a nightmare if you do it wrong. And I've had problems before with some builds while I was still learning, where I grounded it poorly and I got like ridiculous amounts of hum, and once I fixed that, the ground loop just disappeared. So it can be a little tricky if you're doing a brand new build you've never done before. I'm trying to find my shrink wrap. Alright. Let's see. Let's go. I think this is the right size that I want. So one of the things that I had as a suggestion for Phenom is that to help me, because this channel isn't cheap, is that I should probably look to getting some affiliate links to stuff where I buy a lot of my stuff and whatnot. So sadly, I started doing a little research on that. Hopefully I'll find some eventually, but right now the bigger problem I face is that, like, for example, I use Hoffman amps, and I don't think he does any affiliate stuff. I also use Mouser, and Mouser doesn't seem to have any affiliate stuff. So everything I've looked at doesn't do it. He suggested Arrow, and I think I've looked at Arrow before, and they seem like a really cool company, but they're not accepting any more affiliates. So I might put it Amazon, because Amazon has an easy affiliate program, and I have bought several of my things, like my oscilloscope and if you just saw the last video that I did, my new power supply I also got from Amazon. So I do buy it easy my stuff from Amazon. So if any of you guys are buying stuff and want to buy it from Amazon, a little bit of that comes back to me and helps me with the channel. So I would welcome that. So I'll try and get that together though, and hopefully within another video or two I can have that as something you guys can look into doing to help me out. So alright, so we've got the input wire now. One of the things I need to do with it is kind of get it out of my way. I can't see very well. Is I want to solder into that. I'm going to double check before we come off. I think that guy... Okay, I need a 1 meg resistor from that input that goes over to the ground as well. So I need to grab one of those. 1 meg. There we go. And one of the things that can be a bit tedious with some of this stuff is trying to wire it inside of this. So I think I might take a second and pull this out, because wiring in that tight of a space can really stink sometimes. And I'm trying to tighten and so loosen stuff. There we go. Okay. So that way I'll just kind of pull it out in the open area where we can see things a little bit better too, so you guys can see what I'm doing. One tip that I'd learned from someone, and it's not going to work as easily here, is that you can quite often, so if you know the distances you need, is instead solder your jacks together from the outside out here on the front. But you guys wouldn't be able to see that, but it makes it a little bit easier. But what I'm going to do instead is this, we're going to work on, I've got this other more complicated jack, we'll talk about that, but that is going to be hooked into this kind of same stuff as well. So, but the I'm trying to remember now, I always forget off the top of my head, but this is why a continuity mode test helps, is that your tip, I think, is this one right here. And the only way to know for sure is to put that in. You guys can see me. I've got, so I've got the tip of the ground here. It will work for both of them because the tip and the thing are connected, but if you push away, that shows that I'm on the right one, whereas if I come to this middle one, which will be a switched part, and then if I push it away, it will stop beeping because I've broken that connection. So this is the tip, this is the ring, or I mean the switch, and this is the ground. And we're going to talk about tip versus switch ground a lot more with this guy, but in a minute. So I want to solder that guy on here, but also connect my 1 meg to ground between here and ground. So what I generally do is something akin to this, is I wrap that so that the resistor is touching there, can't touch the ground side. Then we want to get, where's my pliers, and create a good physical connection by folding these. Let's see if I'm looking and seeing if there's, oh, it's not super visible. So you see how I've got that resistor there. I will then pull it out and around and bend that back so we get a good solid physical connection, and then I'll repeat the same process the other side as well. This way I've got a 1 meg from the input to ground. This will be connected to ground through whatever the specific layout is. I think, honestly, if I remember right, in this particular layout, this grounding connection jumpers over to one of the other inputs, and we'll look at, I actually have a different thing we're going to load up in a minute to look at it, because this is a fairly complex wiring process. But my input wire does go here, so I can hold that over, get it at an angle I feel is good. Get the angle of the dangle. I got to kind of pinch that tighter now that I have it. As you see, I'm really pinching down on that because I want a very solid, high quality connection. And we will solder that in. Making sure, yeah, that's in frame. So you guys, I've not got too much light in here, do I? So you guys can't see. I know I've got some light, but I can actually dial the exposure down a little bit if it's like washed out. It looks a little washed out to me, but usually the bigger problem I have is dark areas. I want to avoid those, so. Alright, looks good. So that cool. So while that's cooling, I'm going to quickly pull up this other thing that I mentioned. Come on down here, mouse. Get out of there. I need to edit that a little bit. What is it? This is it. Alright, so this, I'm going to actually pull in full screen for a minute, and we'll talk about it really briefly. This was also from the Amp Garage. So let me quickly come down, and I'm going to make this full screen for just a second. So this guy, this is this kind of switch that I'll show you again in a minute, but effectively I have to go through, create a FET ground, FET in, FET out, and then jumper quite a few different leads together, and then connect them off the ground correctly, etc. So you can see in the picture there, I've got the V1 grid coming in and connecting to the input of that jack. Oh, you know what? It's the switch that connects over, so I am fine just connecting the 1 meg ground connection there on the other side straight to ground. So we'll hook a black wire to that. It's the switch that connects up to what looks like pin 6 of the other input jack. So I'm going to go ahead and minimize this back down to the size it was before. But you guys can hopefully see that. I'll make it about as big as I can so it's still visible. So that's what we're going to try and wire up now, is that special jack, which is this guy. So as I understood that pin out, it basically shows pin 9 is the ground connection, and that's this that connects to this plane that connects to the front of the jack. That's pin 9. That connects to pin 2, which is kind of directly below it, and pin 1, and pin 8, and pin 7. It goes all the way through across. So I will have to kind of probably weave those in and out a decent bit. But then we have pins 3 and 4. I'm going to look, see, I can't quite in this light see if these are actually numbered. Oh, they are numbered. In this case, pin 1 is the one directly adjacent to pin 9 here. Oh, so this is a little different than that particular picture. So now I have, this is pin 1. So this is pin 1, pin 9. So I will basically connect a ground through here, 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 and here, I think. But we'll look at that in a second. And just have to get myself a ground wire connected. And according to that, that wire connects into the FET ground, which is this wire here. So I will effectively bring this guy, actually, is what I want to do, FET ground connects into 1. So I might wait to do that last one. I'm trying to think about that. It says to jumper. Yeah, I will actually kind of want a separate wire. Alright, so let's get a separate wire. I'm going to get a lot of lead. And by the way, this is the first time I've connected up this kind of a connection input jack, so I'm also going to be learning with this. So hopefully you guys bear with me. But I'm going to give myself a lot of room so that if I mess something up, I'll be good. But according to this drawing, it's supposed to come in for pin 9, or sorry, it goes through pins 9, 2, 8, and 7. So I think I might actually start, double check which one's 8. So it's saying 7, 8. This is definitely going to be tricky. 7, 8. Alright, let's see if I can massage the tip of this just a teeny bit. Oh, who said that? What? Alright, that came out way dirtier than I meant for that to come out. Alright, 7, 8. And we'll kind of grab that and pull through. You know what I could do is just twist these leads a teeny bit, I guess, And then it just fell out because I actually made it a little bit easier. These, any of these kind of leads, because they're a soft metal, you can bend them if you're careful. So I will just try. Doing that. Now that I have this tip leaning a little bit, it's actually not wanting to go now that I've actually made that a little easier. Hey, you're welcome, Fino. Alright. Let's, alright, so where was 8 again? This is 7, and I kind of turned 8 towards this a little bit. And you guys can just sit and giggle at my dismay of not being able to get this to move the way I want it to. I don't think I just got that, if it'll just play along. Alright, let me just try and bend this just a teeny bit more. There we go. Then it needs to bend back around and connect to 1 and 2. So I will try and get this to go through. There we go. So, almost. I just want to get that all the way through until it stops there. Alright, cool. Oops, I just kind of bent that way. And then I'm going to bend it around to where I have these guys just a teeny bit towards where we're going. Oh, maybe I should just do that and just kind of bring this in through first. Oh, stop. And then I can kind of bend this lead back through 1. This is definitely not exciting or fun. I think I just got it now. Alright, so we now have, and what I'm actually thinking of right here, this may actually be kind of tricky because it wants to have a ground connection between 7, 8, 1, 2, and 9. It wants me to connect the FET ground into this one, but I don't know if there'll be room to still get that through there. Let's look and see, out of curiosity, if there's still... Oh, there is. Okay, cool. We got room. So I don't remember if it was 1 or... Yeah, it was 1. So I'll basically... I won't solder until I've got it into the thing, and then I'll slide this one through once I get the right amount, and I'll solder that. But I will solder the rest of them in and then snip leads excess out of the way. So I'm going to set this guy down right here. If I can find a place to make it want to stay. And I will solder the other connections so that those are soldered in. Alright. Oops. Sorry. Smacking the camera. Let's come at it this way. Alright. I'll skip that one. Get this wire out of my way. And jump to the last one, so I can solder that one later once I get the... Alright. Now, where did my snips go? There. So what I'm going to do on wait for that is I can come over to this guy and look at my leads that are kind of sticking out. Any of the leads that are kind of hanging around. We'll get rid of those because I don't want those potentially touch something later. There we go. Alright. So, that's looking good. I will connect a grounding wire to that one as well. Give myself a good physical connection. And log that up. Oop, already knocked down. No, it's okay. Ah, got that done. Looks like I've scared everybody away. Gotten down to just one viewer, so. And maybe it's just because this kind of stuff is pretty common, and so some people are not too excited about it. But all right, so one thing I can do is strip the wire off of this guy, connect it into my ground. This one, now I think I feel comfortable if I put it in, I'll have access to this pretty easily. And this is one of the things I was afraid of, is this input wire might be... Oh, I gotta first trim that excess lead away from that guy. Alright. I'm going to have to position it carefully. It's visible yet from there, but I have to kind of turn the jack tip around it so it's not touching anything on the FET input. So, let's get that adjusted. Hopefully I'm still streaming. Yeah, it shows streaming. Let's just double check my stream health is okay. Yeah, health is good. Okay. Cool. All right, so just trying to see to make sure. I'm testing my input jack theory. Make sure that nothing here is going to touch the FET area. So I don't know if you guys can see that, but I'm going to try and put a little bit of light on it. One of the things I'm trying to look at is making sure that the tip of the thing isn't touching anything on the FET, no matter how I end up doing this, and it looks like we're good. So, all right. So now I can tighten her back down. All right. Now I'll grab that grounding wire, pull it out, figure out where I want. All right, so first I gotta kind of cut that a little shorter. So this is the input jack. Cool. So let's look at what the next, the next part will be. The FET ground connects in there. So we're going to pull the FET ground over. Oh, actually, I'm trying to think. Before that, I have to connect the other parts into this FET circuit, I think. So let me think. I might want to figure that out. If it's here, input is blue, FET in is blue and connects to 3 and 4. So I'm just trying to kind of measure in my head what that distance will be. I need a little bit of length on this too because it has to go through a couple different points on this guy. So 3 and 4. And I'm going to take my little tweezers here and I'm going to readjust. Oh, that's a little too washed out. Let's get that back up a little higher. That's better. All right. What I'm going to do with these guys is I'm going to kind of also gently twist them towards each other a little bit. So we're running the wire through them isn't so hard. And sometimes I've seen people, when they're doing this kind of stuff, they want the wires to be super short and tied directly in. I am a little bit worried about trying to fit these, so I'm trying to make them actually a little longer than I want them for the final fit, because I want it to there we go. I want it to be able to kind of be bent carefully into place, and then I can kind of clean up the wire and redress if I need to. Alright, so then the FET out connect to 5, and then 6 connects to the other one. So it'll be 5 here. Got right there. Alright. So this is why having a nice layout is good, because some of this is just like, you know, kind of like a recipe. You just have to go and look at what the recipe tells you to do. Alright. Let me snip off the excess of this guy. And this guy should be cool enough that I can do the same thing as well. And then let's go ahead and slip this guy into place, because I just need to do 2 more connections. So I think I should be able to pull that off from here. Oh, that, my friends, might be a bit of a problem. I've got a, the grounding jack is too close to that. So I might have to swap the jack's position there. Oh, I don't know if I have room though. If you can see, my ground wires are getting blocked by this guy. So I will have to kind of carefully, that's something, slanted fender input that's a little bit of a possible problem here, is the, what I'll probably end up doing is, just to be cautious, is I'll put the ground side of this down and touching this, because it touches that, it doesn't work, it matters grounded anyway. So, but let's go ahead and run the FET. Well, actually, now I'm thinking about it, I want to run any other grounds that go here first, so that I can get that guy in. And then the grounding lug itself is also going to potentially contact what is the, you know, the grounds for these other things. So, oops, that's the wrong one. Alright, my input has a good ground. I'll clean up some of the lead dress around this in a minute, but so what I want to do is probably snip this guy about here. Hopefully this is semi-visible and useful for you guys. Please let me know if it's not. So this guy, it says, should connect through here. Now we'll go on top of that. Oh, I got too much crust on that. Let me clean the tip off. Alright. Okay, got that guy. Let's double check and put a little bit more. There we go. Okay. So, there we go. So the only thing I have left to connect in really now is the jumper between the switch input. Is there any other ground that connects here? I better double check that now that I'm thinking about it. So I'm going to quickly look at the layout. And we're going to come up here. This grounding connection has the ground, the ground for these 210 microfarad up the way, I think. Is that what that is? Yes, that connects here. And the reason for that is because that's part of the preamp board. We have the ground coming off the board connecting here as well, which if I'm... Okay, so what I might end up doing right now is putting a second grounding tab here. I don't know. Well, because I'm going to face this battle when I go to put the switch in of being able to get to it. Now, I'll just wait to put this in until we get to that point. So, if that makes sense, I basically need a jumper between here and there, but I can make that a simple small lead. Quickly do that. So I will first connect in there. Hopefully I'm not blocking your view too much here. Oh, this is tight. We'll see if I can get in there. Hopefully that is good. Let me look. I think I got... Alright. And this, I will come basically use the length of it. So one of the things I'll have to do is kind of tuck these away once things are in, but in the interim I have to kind of accept that they're a little tight for now because I don't have the space yet to put that in. So what I mentioned is because this is so tight, the input jacks of these fenders are slanted, I mean the face is slanted, I'm literally going to be tucking tabs to the grounding lug, I think. So to avoid that from being a major problem, what I'm going to do is, as you can see, there are a huge amount of these grounding ones anyway. Those will be the ones that I face towards that lug. That way none of the other ones will ground out accidentally. So, oh, that looks like I didn't get enough solder. Now I'm looking at it from this side. So I'm glad I looked at that. I'll probably do a quick review across the board, but there we go. So this guy will, I will carefully adjust it and get it into that hole, but not until I've soldered all these connections. So for now I'm going to kind of set it up like that and be in my way a little. The ground for, let me look at the ground for this other. So I'm going to pull this ground. It belongs all the way to that. Oh, of course, I'm a little short. So I get to redo that ground wire. It's not long enough. I'm also going to pull ground from, I think, oops, that's not what I wanted to do. I think the ground of this guy, yeah, it shows it kind of connecting here and then shooting up and over. Yep. So this one also, this ground comes up here. So we'll go ahead and get that guy. And then I'm going to have to desolder this because I didn't quite measure it long enough. So we will reheat this joint. Get that out. I'll hopefully be able to use that later. But I have to get a piece of ground wire long enough to go from here to there. So now I will reflow this joint. know if I'll really get to that. There we go. I just want to kind of be able to see this guy bent back. And then we'll put a little bit more solder across the top of it. Get a good connection there. Alright. Much better. Grounded connection there. Well, that wasn't bad, but that's much better in general. So we will now actually I don't want that so loose. So what I think I might do, now that I've gone and pulled it through, pull it back out. I want to run this under here so that we're kind of less visible. Okay, there we go. That is now connected. One thing I will do is clean those out of the way. All right. Well, let's see. So, no. Just trying to think for a second when I'm cleaning up some excess grounds I don't need anymore and think about what's next. So, got the input jack completely wired. I've got my grounds all connected now. I'm just trying to think if there's anything else. If not, I can actually solder that in. Oh, there's the ground off of this though. So the ground off of the ground off that comes off of this guy. Oh, I gotta pull the other one up really quickly. Hold on. So the ground off of pin 9 connects to the ground lug. Okay, so I'll give myself a little bit of room again, like because I have to flex this guy in. I'll probably find out shortly after I do this. Actually, I'm gonna give myself a little more lead. That I've missed a ground, but I'm hoping I missed a ground. I've just double checked it. If not, I'll just have to pull this jack out carefully. Now, one of the trickiest parts of this is going to be putting enough solder to flow all the way to the bottom on all those grounds going to that spot. So, but we'll see what happens. It is flowing in. want to get a very large blob of solder down in here because I'm connecting a lot of grounds. Alright, I think we're good. So what I'll do is let that harden up, and it's taking a minute to harden up, and I will then go through and clean that up. But okay. Oh, too late. I missed the drop flux on it first. Actually, what I had done with that one, though, was I'd scraped it really heavily with a wire brush and gotten the metal clean and open just a day or two when I first put it in there. So I don't think it's had a chance to really build up a lot of corrosion on it since I did that. So, and it looks like it bonded pretty well in there. So I will now kind of carefully unwind any of these leads and snip them. I'm not too worried about them because they're ground and they're supposed to ground, but you don't want them accidentally just being hairs, if you will, just like laying around that could potentially grab something and short something you don't want shorted. So I'm just trying to get any of the wires that are really loose and long snipped away. Alright, that ground is complete. I will now try again to carefully reinsert this with my grounding stuff down by that side, so that if it does touch, whatever it touches there is just an okay and acceptable grounding point. So if I find for some reason I've wired this wrong and it's not giving the output, we'll have to face that battle, I guess, when we get there. And this might be a tricky part too, is getting this to... Is this a different size? No, that's not the right size. This should be the same size as that one. Fitting. This is 13. I don't know if 11 will work. We'll try 11. No, it looks like it's 12. Let me grab a 12mm wrench and see if we can get that. Alright, let's see if that's the right size for this guy. It is. And I will possibly be bending some of those leads by tightening this down, but I have to get it tight. But those leads are touching the ground lug, and they are the grounding leads. Or at least I hope they still are. Nope, that rotated around a way I do not want. So let's undo this a little bit again. One of the things I've got to be very careful of is... Alright, let me just... So this top one up here, if you guys can see that, is the purple wire, and I cannot have that touching ground. find out shortly, not shortly, eventually anyway, this was done correctly. But, alright, so that is in, socketed and set up. So, and at this point I've reached my 1 hour point. I'm trying to think, well, it's not as much the shorter screw because I'm not touching it now. But the way I have the tab set up is the tab lifts up like this where I'm soldering to, and then the leads are touching it. But they're all the ground leads anyway, so I'm not too worried about it. I guess another potential thing I could do, maybe if it doesn't work, is I'll loosen the screw and rotate that tab around away more, pointing out this direction, see if that helps. But I think it looks like it worked. That is a good idea in theory. I think the problem I've had is I had some shorter screws and then used them all, and I went to buy some more and I bought the wrong length, so I've got some longer ones. I need to go buy some more of that shorter length. But alright, so let's see what's next. I think I'm going to talk about what's next, but I don't think I will do what's next for a little bit here, because unless it's easy. But well, I could do some of this stuff like the volume pot is not directly connected as you see. It comes from the treble, and then it has 300, can't read that very well, but a 300, I think it's a 300 picofarad cap jumpering over to the switch, the bright switch, and that has a 270K over. I could start doing some of this stuff, but I'm at an hour or two, so I'm just going to talk through it for a minute. One of the things that's interesting to me is the output of this anode. If you come over here, where the first input comes, it comes out and around, oh, that's the ground, sorry, the blue is the anode, comes out and around to this guy, to this 33 picofarad capacitor, into this 100K, and then this 0.1, that yellow comes over and into the jazz switch. So that's, that'll be connected there, but for now, I could actually wire up the volume pot by connecting one lead of the volume over to the middle of the treble. And I don't want to, interestingly enough, I guess I don't know if I want to do this anyway, because I don't want to solder until I'm ready. I've got all those points in, so I might actually need to kind of wait to do some of this stuff. I'm going to have to think about it, but I think I'm going to wait to do that until I actually drop the board in. So what I might do is drop the board in for my next video. We'll put the board in and go from there. The 22 meg resistor, this is what I've got here. That's going to go and connect into the treble as well. So I've got volume, and I've got treble, so it would kind of connect into here. But basically I'm going to be jumpering this lug to the middle lug of the treble, the middle lug of the treble, or the end lug of the treble, which will be this one over here, connects to this 22 meg resistor over to the rock switch. The problem I'm going to have is my rock and jazz switches are kind of over here. I didn't have because of the chassis being pre-drilled, so I'll probably end up having to connect a wire to one end of it and then cover it with a shrink wrap after soldering it, and then run a longer one to those sides. But we'll get to that. So, and that will be kind of interesting for me to do while I'm looking down like this. But the good thing is you guys will be able to see it. So, I think at this point I've hit my hour. Hopefully, everybody's enjoyed what we've seen so far. The guys that were in, whatnot. But we will resume this on the next video. So please do tell me if there's any other things that I'm missing in this. Please do chime in with chat with your suggestions, and we will see you next time. Thanks, everybody. Please do like, thumbs up, subscribe, and hopefully the channel will continue to grow. Could I talk about what is the best choice of cap types? Film, mic, ceramic? Yeah, so that is a heavily debatable topic, and a lot of his opinion. So there's two different things that are part of that debate. One is which is the cleanest sounding one that doesn't add color to your tone. The other one is some of them people will say that the color they add is actually desirable. But there are some specific series of ceramic capacitors that are designed to work in audio circuits, and they're supposed to be low noise. And one of the things I want to do is use one of those in this because I found out by talking to one of the guys in the forums that these ones are too clean and end up giving kind of a higher bright end, whereas the ceramic do create a little bit of tone filtering that's good, changes the tonality of it. So I'm going to probably buy two ceramic 270 picofarad capacitors. Film capacitors are these bigger ones. Those are great for almost any audio use, and there's different types and they have slightly different characteristics. These are 7 to 15P series. The mic type like this, the reason the film aren't done in smaller sizes, they just don't work. You can't do a film capacitor in this small range. So you can either do these mica or the ceramic. The bigger film type, there's a lot of different ones. There's mylar, there's polyester, there's tons of different ones. But from what, and there's like there's some yellowish ones. I can't remember the brand what those are. I think those are usually CDE. These are used to be Cornell Dublier, or no, they used to be, I think, Vichet or somebody else, but they all kind of have become one big conglomerate. But effectively, almost any of these kinds of caps will work. There's been a lot of debate, and it's hard to prove as to which ones will sound the best. I'm trying to use the types of caps that he tended to use for this build on purpose, but I also have a lot of amps using just the standard, cheapest Zycon style capacitors. They kind of look similar to these guys, but they'll be more of a brown color, and I've had no problems with those. So hopefully that makes some sense, but effectively the cheapest ones you want to buy that are at least film level are the best ones for audio grade. If you can't use those, then mic is generally the best for cleanliness. But if you get the right kind of ceramics, those work really well also. So it's just, the problem is a decent amount of the time some of those manufacturers got the cheapest ceramics they could get because they just needed the capacitance rating, and they added a little crummy noise to the tone, and they just didn't care because it was cheaper. So I can't give you the solid answer. A lot of that is a huge debate that I tend to personally be an engineering type guy that wants to say I need proof that it actually sounds better, and I also have a little bit of hearing damage, so I may not even be able to hear it. But so kind of the sound is in the ear of the beholder. So I think you'll have to spend some time yourself trying the cheap ones first if that's what you can afford, and they will work perfectly for the use. And then if you later on build another amp and you have a little bit more money saved up, I would say then maybe start spending on a little bit more expensive capacitors and figure that out. All right, cool. Everybody have a great day. Thanks for joining me today. I will see you on the next video. Cheers.